Precalc chapter 7 section 6, we're dealing with inverses of matrices and how to solve using inverses. So we should have some knowledge of inverses. We've used them prior in math. For this equation here, we can divide both sides by 3. Why do you divide by 3? This is the inverse of multiplying, the opposite operation, the inverse operation. So there's a few other ways of writing that. Instead of dividing by 3, we could say that we're going to multiply by the reciprocal. So multiply by 1/3. So this is called the multiplicative inverse when you multiply by the reciprocal. And so then we have 1/3 times 3. It's the multiplicative inverse because 1/3 times 3 over 1 is 1. It undoes what's occurring. There's another way we could write this. Instead of writing it as dividing by 3 or multiply by 1/3, and it's multiplying by 3 to the negative 1 power. Multiply both sides by 3 to the negative 1. Why is that? Because 3 to the negative 1 power is the same thing as 1 over 3. And so this will help you out with today because that's really what we're doing with our matrices, is using this notation as the inverse. And so this still is going to give us x is 9 because this is really 27 divided by 3. That's the inverse. So we want to simplify 8 to the negative 2 power. That's the same thing as 1 over 8 squared or 1 over 64. For a square matrix, a to the negative 1 as a notation is an inverse of a if a times the inverse is the identity matrix I. Now, I is the identity matrix. A matrix, you have the downward diagonals are going to be 1s. Everything else is going to be 0s. So I just made a big matrix here. Just show you how we had the downward diagonals are 1s, all the other values be 0s. And it's got to be a square matrix. So whenever you take a matrix times the inverse and you do the inverse times the matrix, both of them produce the identity matrix. That's how you verify two matrices are inverses of each other. So if there is an inverse, A is called invertible or non-singular. If there's no inverse, it's called singular. Some terminology. So let's verify that B is an inverse of A. So to do that, we got to recall that we have to do A times B, and we should get the identity matrix. So if we multiply those in that order, and we got to show both directions for multiplication because it's not cumulative for matrices. If we multiply that, we're going to do row by column. You remember how to multiply row by column. So we multiply 2 times 3 would be 6. Plus 1 times negative 5, which is 1. And so then we can do the row times the second column. So 2 times negative 2 is negative 2, plus 1 times 2 is 0, 0, 0. And then 5 times negative 1 is negative 5, plus 3 times 2 is 6. Negative 5 plus 6 is 1. So we get the identity matrix. We have to repeat that process for B times A. So then we gotta change the order. 3 negative 1, negative 5, 2. Multiply to 2, 1, 5, 3. And so you multiply those, row times column, you get 6 plus negative 5 is 1. And then row times second column, so 3 plus negative 3 is 0. Row times column, negative 10 plus 10 is 0. And then row times column, negative 5 plus 6 is 1. So they both produce the identity matrix, therefore B is an inverse of A. And that's how you verify that these are inverses. So 2 by 2 inverse. Now how do you find the inverse? So if we have this matrix A, which is A, B, C, D, so you define those variables, then the inverse of A is found by using this equation where it's 1 divided by this operation, A times D minus B times C. And so these come from the letters within the matrix. So you're going to do A times D, notice, is the downward diagonal. B times C is the upward diagonal as you read it left to right. Now we cannot divide by 0, so notice how the denominator cannot be 0. And so if it is 0, you're not going to have an inverse, and so it's invertible if it's not 0. You're going to take this fraction and you're going to multiply it by a matrix where the D and A have switched spots and the C and B have become opposites. So that's what we're going to do to find the inverse for a 2 by 2. So let's do it for this 2 by 2 matrix right here. So let's call this matrix B. Let's find the inverse of B. To find it, it's 1 over A times D. So that's going to be the downward diagonal, 1 times negative 3. Minus the upward diagonal, 2 times negative 2. And then we're going to take that times the matrix where the downward diagonal switches spots. So the negative 3 and 1 have switched spots. And this becomes a negative 2, this one becomes a positive 2. These don't switch spots. The upward diagonal does not switch spots. They become opposite. So this is negative, this becomes positive. The downward diagonals will flip spots when you write this matrix. So we simplify this. This is negative 3 minus negative 4. So negative 3 plus 4. So you get 1. So this ends up being 1 over 1 times the matrix. Negative 3, 1, negative 2, 1. Now this is just a scalar. Usually you have to multiply through this matrix by the scalar. This one you just have that matrix, negative 3, 1, negative 2, 1 as the inverse. So there's your inverse. For a 3 by 3 matrix, for this one you're going to use a calculator to do this. And so I can show you tomorrow in class. I don't have it on this computer. But we're taking the, if we call this matrix C, to find the inverse of C, what you do is you plug C into your matrix window in your calculator. So you need to punch in this matrix, the 3 by 3 matrix, and then you're going to call up that matrix in your calculator and you're going to use the negative 1 key. So x to the negative 1, this is the key to use. So I punch in matrix C, and I use the x to the negative 1 key on the calculator. There's actually a calculator key I would use to find the inverse of that. So try that, punching that in your calculator if you have that at home. The answer you get is no inverse. And we can kind of see why that is, because if we look at all these zeros, it's going to produce a denominator that's 0, which makes it non-invertible, or singular, we could call it. So here's what we're going to use inverses for. We're going to solve systems using inverses. And on your test, I'm going to ask you to solve using inverses, so I need to see the work for that. Let's first solve this equation for x using the same notation. So if a times x equals b, and I want to solve it for x, I could do the inverse of a times a equals b times the inverse of a. And that'll isolate x. Now when I write this, I'm going to write the inverse of a first times b. And then this is how I'm going to find x. We're going to do the same thing for matrices. Now when we write this, we're going to want to put the inverse first for this problem, and it's because of the match of the matrices. We have to make sure that the rows and columns match so we're able to multiply them. So first thing we got to do is change our equation into a matrix form. So we have the coefficient matrix. So we have the 1, negative 2, 2, negative 3. So 1, negative 2, 2, negative 3. There's our coefficient matrix. We're multiplying those by x, y. If you actually multiply these together using your pattern for matrix multiplication, 1 times x is 1x, plus negative 2 times y, you get negative 2y. Notice how you get the same quantity right here. It's the row by column, so 2 times x, 2x, plus negative 3 times y, negative 3y, is the same equation. So mathematically, if we multiply these matrices, you get the actual equations in the system. And it equals our solutions, or our constants, of 4, 2. So this is still mathematically true. Now on your calculator, or on the work I would show, is that I would call that this is matrix A, I would call this matrix X, and I would call this matrix B. So then to solve for X, I want to do the inverse of A times B. And so this is really the work I want to see, and you can actually punch this in the calculator to find the inverse times b. Because I don't have a calculator, I'll actually do it by hand. So let's find the inverse of A, so the inverse of this matrix. So I'm going to do 1 over the downward diagonal minus the upward diagonal, which ends up being the same exact matrix we were just finding. Negative 3, 1, switch the downward diagonal. Upward diagonal becomes opposite signs. And then we can distribute through. This is 1 over 1, so you just get the matrix negative 3, 2, negative 2, 1. Same matrix we found in the previous slide. So to solve for x, I'm going to take these inverse matrix, and we're going to multiply it to matrix B, which is 4, 2. Notice how the columns in the first matrix have to match the rows in the second. So we have 1, 2 columns, and then we have 1, 2 rows. So then those match, and so you can actually multiply this. If you reverse the order of your multiplication and did b times the inverse of a, you would not be able to multiply. And that's why it's important for this to have the inverse of a first. So if we actually multiply these out, negative 3 times 4 is negative 12, plus 2 times 2, 4. And then we have negative 2 times 4 is negative 8, plus 1 times 2 is 2. And then our final answer here would be negative 8 over negative 6. So these are the results. So this tells me that my x value here is negative 8, and my y value is negative 6. So x equals negative 8, y equals negative 6. There is the answer. So we can use the inverse matrix to solve systems of equations. Now, for this one, it might have been more beneficial just to do it algebraically, but as these systems become larger, the inverse function will be quite helpful. And so using the calculator to actually find the inverse and to do this multiplication really expedites the process. Here's a system of equations which we could put into matrix form, and then we can use inverses. So to solve that, to find x, y, we're going to take the inverse, that's the negative 1, times 8, 1. So you can kind of see the notation that the book is using here. Here's your inverse function, so the inverse of this matrix times the matrix 8, 1. If you do that, they're showing here's the inverse, this is the inverse they got, times the 8, 1, and then here's the results. Now, the work, again, I'm expecting you to show is if you want to call that A, call that X, call that B, and then you know how to find X is the inverse of A times B. This is good work, just showing that you're assigning the matrices, the variables, and you're showing what you're doing to the variables on the calculator to find the solution. And so you're doing that on the calculator. You're still using the inverse method, but you're using calculator to help you out. Call that good for the night. We'll see you tomorrow.